Hello, my name's Chris Kurzik, and I'm the Principal Engineer at Athabasca Engineering Solutions, AES for short. And what does AES do? Well, first of all, we provide third-party value evaluations. We provide training and certification. We provide equipment re-rating.
Back to our continuing presentations on minimum design metal temperature. In this series of videos, we're going to go into Section 8, Division 2. And this presentation will contain the following material. First of all, there'll be a discussion on nameplate requirements. Secondly, material toughness, general requirements. Thirdly, we'll talk about governing thickness and how it relates to Division 2, and a little bit of discussion how it compares to Division 1, and some material toughness curves, and you can see the differences between from our earlier presentations to this one, how they're different and how there's more factors to consider or in designing it, because it's a more of a precise type of a calculation or determination. About the nameplate requirements, what you'll find in Division 1, most of the requirements are in UG 21, whereas most of the requirements you'll find is in Part 4152E in the 2021 version, and also very specific requirements for stamping and nameplating, right down to the letter size, everything in Annex 2F. The units parts, a discussion about this acceptable units is found in 1.4H, and typically the client has specific requirements. Some cases the client requires dual units. In that case, what we used to do is have a nameplate for each of the units. So the MDMT at the coincident pressure, must be equal to the MAWP. So when there are multiple MAWPs, the largest value shall be used to establish the MDMT marked on the nameplate, just like Division 1. So this is what you'll find on the older U2 units. So if you've got a plant that's, I'm not sure which revisions ago, but this is one of the original ones, stamps that you'll see on nameplates. And this is the newer one. And basically, Division 2 has two classes of designs, and one has a lower safety factor than the other. And I have another video on the overview of the allowable stresses. You can look it up in our library, and it's got lots of information about Class 1 and Class 2. So there's a few other rules to keep in mind with the boiler pressure vessel code nameplate requirements. Vessels or components operating below the MDMT. Let's talk about that. So when vessels or components may be operated colder than the MDMT stamped on the nameplate if, and this is found in section 311.7 for more detail, but in essentially if the provisions of 311.2 are met, then you can reduce that MDMT below that, provided that you're not any colder than 104 degrees centigrade or minus 155. You'll see that when we go through this in a little bit more detail. So minimum operating temperature is 104 no matter what you do. And another thing is the thickness is based on pressure only. So the calculation for where we looked at the stress reduction, taking advantage of the available unused stress in a part to reduce your MDMT, they have specific requirements for that, and they require if you're going to be working below your MDMT, you have to it has to be based on pressure only. So you need to use the pressure temperature ratio. So let's look at the Division 2 material toughness requirements as quoted in 311. So basically what they're saying is the Sharpie V-notch impact testing shall be made for materials used for shells, heads, nozzles, and other pressure containing component parts, as well as structural members attached for structural integrity of the vessel. So that's like supports, for example, and anything that would for integrity. And so unless exempted by the rules of 311. So, the exemptions are based on, the MDMT, the thickness, and material specifications. So we're going to get into that in a minute. Material toughness requirements, general requirements. So we're talking about heads, nozzles, and other pressure containing components, okay? And so we have, there's groupings, how it works. So we were going to talk about carbon and low alloy steel, except bolting, where we'll spend most of our time, and this is located in section 311.2. In particular, we'll look at table 3A1, and that's the listing of the applicable materials that are recognized by the standard. And then we'll have the second group of materials. It's called quench and tempered steels with enhanced tensile properties. There's special considerations required for those, and because they're more susceptible to cracking. And so 311.3, we go to table 3-A2. The third one is the high alloy steel except bolting. So that's like, your 304 stainless steel, 316, and your higher alloy steels. And that's probably the second most one after carbon steel that you'd probably run across. Quench and tempered steels, I rarely run into those, except for other applications, which are non-pressure, but you do see them, and they're available. So we'll go so back to that. So the bolting in all these requirements are found in another section, but 311, then of course it's got another table organized, in a very nice fashion. And then there the other classes, the non-ferrous materials. Okay, so that it can include titanium and aluminum. And it's listed because, in particular, the high alloy steels and the non-ferrous steels are listed for MDMT because they are used typically for cryogenic applications. And so there are some applications where you have aluminum and you have to impact test it or stainless steel because you're running that cold. The only case I've ever found was, helium applications, which is very, very specialized, but the rules are there. So governing thickness, step 1 is very similar to Division 1, except that it's more in depth. It really differentiates between post-weld heat treatment and so on, and it basically you're sharpening your pencil and you're getting a more precise answer. So there's more options available, and so that's the first step. Just like the Division 1, you need to determine the governing thickness. And the section to refer to is 311.3b in the 2021 code. See that in 311.3b, there's governing thicknesses for welded parts, and there's another section for non-welded parts. But they have a series of sketches, and what's nice is everything is self-contained in Division 2. So they have their own figures, even though in a lot of cases they're identical to the Division 1, but you don't have to start mixing and matching your references. You can stay within Division 2 and work within it. So this is the same. What I did is I tried to show you the same kind of equivalent table, and so you can see it's basically, in this case, it's identical. It's for butt welded components, and so these rules apply. So instead of, in this case, you would go to Figure 3.9 and Sketch A, and there's a whole series of sketches. Some other welded part examples shown here. This in Part B, we're talking about corner and fillet or lap weld joints, and you can refer to Sketch B for those. And so you have your different configurations for those components, and below, where you're governing thickness, you take the minimum thickness of Part A or Part C, and and so on. So that's basically how you do it, and the tables are pretty good. I've never had a problem with them. Part C is for flat heads and tube sheets, and the larger of B basically for flat components, and then you take the flat components and you divide them by 4, and you can see a figure 310, excuse me, for more details. So here's an example of what I mean by the governing thickness. You can take the thickness of the part, TA shown here, and you can divide that by 4. And then you take TC, right, for the other part. And then basically this is very similar, or pretty much exactly the same as Division 1. I'm going to continue here. You can see the other configurations, same formula, a slightly different design. And we can continue on here. There's another variation shown there, and that's for a flat head or tube sheet formed on a corner with a cylindrical, with a joint for a cylinder. And then the last one that they show is D, which is 2 flat plates with a corner joint. And so they're showing you the formula for governing thickness. Thicknesses for non-welded parts or castings, which are becoming more prevalent with the newer technologies where that basically make parts without welded components. And so refer to 311.23 Part B 2, 3, and 4. And basically we take the largest nominal thickness, or for bolted flanges, flat heads, or tube sheet, the larger of B above, or the flat component thickness divided by 4. So it's a similar rules to welded cast or parts, and also very similar to Division 1. And for dish heads, we take the flat flange thickness divided by 4, and this is the maximum of these two variables, or the minimum thickness of the dish part, so whichever is larger. When we jump in here to governing thickness, this is welded attachments. So there's, if you look at Figure 3 on Part C, you'll see the first one on the left. This is particularly for example, a vacuum ring would be a very common example, and you can see how it's attached here. And basically the rule is the minimum thickness of A and B. So it's always important to make sure that you don't penalize yourself by making a part unnecessary thick or thin, right, based upon these ratios. Also, for example, here's another common one where, say, you have alloy steel and you want to weld what we call a poison pad material on there, like carbon steel, and we want to make sure, I typically try to match the thickness of the plate or go a little thinner, but you shouldn't go heavier than that, because you could have an issue. So anyway, so there's one example, and here's another one right there. This is the integral reinforced weld neck flange. This is for, high pressure flanges, right? And very common nowadays. And here is, you take the minimum of the thickness of A or C. 1123C has more comments on welded attachment that you should be aware of. The first one is you have to evaluate all the components as separate components, and the components that are separate are the shells, the heads, and nozzles, manways, reinforcing pads, stiffening rings or vacuuming rings, flanges, tube sheets, flat cover plates, backing strips, even backing strips, and attachments that are essential to the structural integrity of the vessel when welded to pressure retaining components such as separate components. So again, these are considered to be components that are essential to the structural integrity of the vessel. So the welded, and essentially these components must be welded to the vessel. This gets interesting when you have a skirt attached to a vessel, and then you have to consider those issues. So let's continue on to step 2, which is the applicable material toughness curves. And essentially, I have a note here about that. So you want to determine the applicable material toughness curve in this second stage using figure 3.7 for parts that are not subject to post-weld heat treat, and then figure 3.8 for parts that are subject to post-weld heat treat. And remember, this is for carbon steels, right? Low alloy stuff. And so you need to see that figure, and you need to also get the minimum yield strengths of the materials as well. So you can see that this is a little bit more in depth of an analysis than Division 1, where you can take advantage of the post-weld heat treat code or not, and whereas the rules are a little bit more general in Division 1. So let's continue. Look at 3.11.2 material toughness requirements for carbon low alloy steels, except for bolting where we use tables. So 3.11, you can also use table 3.14 if you want an exact answer. For presentation purposes, I tend to like to use a chart because it's easier for people to understand what you're trying to do. But if you're using a computer model and you want more precise, then table is the way to go. So here is the one for corresponding to parts not subject to post-weld heat treatment. And we'll compare those. So 3.8 is, or equivalent to 3.15, is for post-weld heat treated and non-welded parts where you don't have these residual stresses or they've been removed. And so you can see, you can compare those parts against non-post-weld. You can see over here that you're basically sitting at, see, your curve D is about what, minus 38-ish, but look at where your curve D is here. You're sitting in, you're much lower than that. You're sitting about minus 44, and the same as an A curve component. Over here, you're sitting at 20 centigrade, and then here, because you're getting, it's taking advantage of that, then you get the credit right away. And before, you'd have to get that credit with Division 1, as a separate step, but they've incorporated that all together. Take a look at 3.11.2 material toughness requirements, carbon and low alloy steel except bolting. There's more notes that I'd like you to take a look at. Under figure 3.8D, There's issues about cooling rates. They have very specific requirements for the processing of the material that you just don't see in Division 1 to this degree. And part 2 as well. When you buy materials in Division 2, there's a lot more controls and a lot more inspection required. So your cooling rates have to be greater than air rates, and you have to have followed by tempering. You can do the tempering, right, and it's permitted, but your cooling rates have to be higher, and you have to have a fine-grained practice, and that's very indicative to Division 2. And basically the standard is SA20 for following those requirements, and normalized cooling. Normalized rolling condition is not considered to be normalizing. Once again, very specific. So do not go into Division 2 unless you know you can get the inspection and that your vendors really understand those requirements, because things can get difficult very soon. 311.2 in terms of the impact, the toughness and the thickness. So you can see here from there's a statement buried within 311.2.3D. When you're greater than an 1.5 inches thick, thickness requires impact testing. If you don't have post-weld heat treatment. We could take a look at the thickness limits, okay? And we looked at the thickness about greater than 1.5 inches thick, and that's sort of a red flag anyways with Division 1 as well. So whenever you get to that, you should always think about extra requirements like post-weld heat treatment, okay? So 311.2.3E, if you're less than 2.5 millimeters, which is basically 0.1 inches in thickness, then you can be exempt. Then you basically no impact testing is required, but you're limited to minus 48 degrees centigrade or minus 55. The second thing is, non-post welded. This applies only to non-post weld heat treated and post weld heat treated P1 materials.
I hope that you found this presentation useful and valuable to you. This was provided by Athabasca Engineering Solutions. We'd love to hear your feedback and your thoughts on further videos. And we'd love to hear from you. Maybe we can do some business. Please subscribe to our channel so you don't miss a thing. Take care for now.